Compare and contrast SAGE II with Picasso-Cena.
How will Picasso-Cena help scientists measure aerosols more accurately?
Dr. Anderson?
Hi, Jennifer. Hi, Van.
Hi.
Dr. DeYoung told me you guys were coming over to learn how a satellite instrument measures aerosols.
Yeah, actually he thought you could help us out on information about the satellite system you use.
I'd be glad to help. I'm involved with a satellite instrument called SAGE II, which stands for Stratospheric Aerosol and Gas Experiment. The less sunlight that gets through the atmosphere at specific wavelengths, the higher density of aerosols there are in the atmosphere. A way to demonstrate what the SAGE II photometer might see up in space is to hit two erasers together and shine a light through the dust. This light from the flashlight represents the light from the sun. Researchers look at the reduction of the sun's light to measure how many aerosols there are between the sun and the satellite. Remember, SAGE II only uses light from the sun. You know, Van, when I was a student in college, I had to actually collect samples from a real cloud.
Really?
Oh yeah. I would climb Mount Mitchell, North Carolina when the clouds would collect around the mountain. Droplets would form on a Teflon string collector I would hold up and would run down into a container. It demonstrates the same principle which applies when water vapor is attracted to an aerosol in the atmosphere to create drops in clouds.
Cool.
Say, how would you like to learn about the Picasso-Cena system?
Okay.
Picasso-Cena, like SAGE II, will be a satellite-borne instrument that measures aerosols. But it is quite different than SAGE II in that Picasso-Cena uses active remote sensing, while SAGE II uses passive remote sensing. My colleague, Dr. Ali Omar, is developing the Picasso-Cena system along with Hampton University, NASA Langley Research Center, Ball Aerospace, and the French Space Agency, CNES. Why don't I send both of you over to see him right now?
That would be great.